First thing to do is to write our equation, which is 1 over 6x minus 1 over 5x is equal to 3 over 25. First thing to do is to subtract 3 over 25 on both sides so that we will be left with 0. On the other side as well, so you will be able to cancel it. Now we are left with 1 over 6x minus 1 over 5x minus 3 over 25 is equal to 0. Let's get the denominator by multiplying 6 and 5, which is 30x and 25. Now let us divide the denominator in each term. We are left with 5 times 25 minus 6 times 25 and negative 3 times 30x is equal to 0. Let's distribute it. We now have 125 minus 150 minus 90x. And as you can see, we have like terms. Let us combine those, which is 125 and negative 150. We are left with negative 90x minus 25 is equal to 0. Let's transpose that. Now we have negative 90x is equal to 25. Let us isolate x by dividing negative 90 on both sides. We're left with 25 over negative 90, and we can actually simplify it by dividing 5 on the numerator and the denominator. We have left with negative 5 over 18, which is our final answer. Let us first check it, and this is what it looks like. First, let us write our equation, which is x minus 9 all over x plus 10 is equal to x over x minus 8. Let us subtract x over x minus 8 on both sides. From this, we can actually cancel the right hand side and be left with 0. Now we are left with x minus 9 all over x plus 10 minus x over x minus 8. Next thing to do is to get the denominator, which is the 2, x plus 10 and x minus 8. Let us divide each on each term. We're left with x minus 9 times x minus 8 minus x times x plus 10 is equal to 0. Now let's conduct each operation. Let's distribute each. We are left with x squared minus 8x minus 9x plus 72 minus x squared minus 10x is equal to 0. Let's rewrite it again. X squared minus 8x minus 9x plus 72 minus x squared minus 10x is equal to 0. Let's combine the terms negative 8x and negative 9x. We now have x squared minus 17x plus 72 minus x squared minus 10x is equal to 0. Let's combine the like terms. We will be able to cancel the x squared. And left with negative 27x plus 72 is equal to 0. Let's transpose that. Now to isolate x, we are going to divide negative 27 on both sides. Let's simplify that by dividing 9. We now have positive 8 over 3, which is our final answer. And this is what the whole solution looks like. And this is our checking. First, write our last equation, which is 5x plus 1 all over x plus 3 plus 5x minus 3 all over x minus 1 is equal to 8x squared over x squared plus 2x minus 3. Now this denominator, we can actually factor it to x plus 3 and x minus 1, which you can observe is actually present on the other side. Now let's subtract 8x squared on each side so that we will be able to cancel it on the right hand side and be left with 0. From here, you can see that you will be able to cancel it. Now let us find out our denominator, which is actually x plus 3 and x minus 1. Oh no, that's not a straight line. Let's do it again. That's better. Now we now have x plus 3 and x minus 1 is our denominator. We are going to divide it on each term. Now we are left with 5x plus 1 times x minus 1 and 5x minus 3 times x plus 3 and negative 8x squared is equal to 0. Now let's distribute each. Now have 5x squared minus 5x plus x minus 1 and 5x squared plus 15x minus 3x minus 9 minus 8x squared. Now let's combine the like terms on each part. We now have 5x squared minus 4x minus 1 plus 5x squared plus 12x minus 9 minus 8x squared. Let's combine the like terms. For the x squared, we are going to have 2x squared. For the x terms, we have 8x minus 10. Now let's rewrite it again. 2x squared plus 8x minus 10 is equal to 0. Now from this, you can see that we have a coefficient for the first term. To be able to make things easier, let's divide 2 on each term. We now have x squared plus 4x minus 5 is equal to 0. Now, we can actually factor this to x plus 5 times x minus 1. Now, let's equate each to 0. Now have x is equal to negative 5. And x minus 1 is equal to 0 is equal to x positive 1. Now our final solution is negative 5, which is the only one that is sufficient for the equation given, which you can observe from the checking.